Are you looking to build a drone and don't know where to start? Then this video is just for you. In the first part of the series, we'll discuss everything you need to make a drone. We'll discuss the flight controller, the motors, the ESCs, the power distribution board, everything. So by the end of the series, you will be able to make a drone like this. So now I will show you all the components that you are going to need to make yourself a drone. So first is the frame. It's going to hold all the components together. It needs to be strong and lightweight. Next over here is our landing gears. These help us to have a soft and safe landing. Over here is our brushless motor. These are necessary to get our drone airborne. This over here is our FS10B receiver, which is going to pair with our transmitter so that our drone has a long range. This is the power distribution board. It transfers all the power from the battery to all the components of the drone. I am using this 11.1 volt LiPo battery which powers the entire quadcopter. And in the end I am using this 30 ampere ESCs which control the speed of each individual motor. So these are the propellers. These allow a drone to have enough thrust to take off and land easily. The last but not the least is our flight controller. This flight controller is the mind of a drone. It controls all the functions, the navigation, the takeoff, the landing, everything. One important thing that I need to highlight to you guys is compatibility issues. Sometimes while buying these motors, they may not be compatible with certain type of flight controllers or ESCs. But don't worry, in this video I am going to tell you how you can buy them and how you should look for them while buying. So let's get a detailed look at each of the components. So first we are using the F450 quadcopter frame. It is made up of glass fiber and polyamide, which are lightweight materials which provide sufficient strength for our entire quadcopter. Second, we are using the A2212 1000 kV brushless motor. These motors have a RPM of 12,000 when powered by a 12 volt battery. These can easily run on 2S to 3S LiPo batteries. Third, we are using the 30 ampere BLDC ESC. ESC controls the speed of each individual motors. These ESC run on 2S to 3S LiPo batteries. Make sure you select the right ESC according to your drone because the selection of the right ESC not only improves throttle response but also enhances overall flight stability and control. Fourth, we are using the 1045 quadcopter propellers. Larger propellers allow us to have more thrust, which are better for heavy drones. These are 10 inches long, providing more thrust and efficiency. They have a pitch of 4.5 inches. Higher pitch in propellers increase the overall speed of the drone, but it also increases the current drawn from the battery. Lower pitch of propellers usually increase the efficiency of the entire quadcopter. Fifth, we are using the FlySky FSI6X 10-channel transmitter. This transmitter operates on 2.4 GHz frequency. This band is common due to its balance between range and the interference resistance. This transmitter has 10 channels which can be used for things other than the throttle, yaw, pitch and roll and can be used with its switches and knobs. Sixth, we are using the FSI-A10B RC receiver. It has a number of 10 channels. It has 140 RF channels. It operates on 2.4 GHz. Its operating voltage is 4 volts to 6.5 volts. This system ensures no interference in the radio signals, making the flight smooth and stable. 7th, we are using the 11.1 volt 3300 mAh LiPo battery. 3S or 11.1 volt battery is sufficient enough to power our entire quadcopter. 3300 mAh allows our drone to have a longer flight time. Larger mAh battery also increases the weight of the overall drone. 8th, we are using the cross-flight power distribution board. This power distribution board handles the combined current draw from all our motors and electronics. It is compatible with the flight controller as well as with the motors and ESCs. 9th, we are using the RadioLink TS100 MA10 GPS module. This has a quick refresh rate which enables us to quickly see our drone's location on the Emission Planner app. It has a built-in magnetometer which provides heading data. It has an accuracy of plus minus 2.5 meter horizontal and plus minus 0.5 meter altitude. It needs a voltage of 3.3 volts to 5 volts. It allows us to have different types of functions which include position hold, RTL, waypoint navigation and geofencing. The last but not the least is the RadioLink Crosslight Flight Controller. It is compatible with the various UAV platforms like Mission Planner. This flight controller supports multiple flight modes. It has integrated gyros, accelerometers and magnetometers. It has a OSD display for real-time flight info and has fail-safe features for enhanced reliability. It also supports telemetry and GPS module for real-time data communication. So what's next? I've already explained you each component in detail, and if you get these components from any online store, you will not face any compatibility issues. So in the next video, I will show you how you can build your drone and how you can configure it. So I'll see you in the next one. Don't forget to like, share and subscribe. Stay tuned. Bye bye.